Hello, everyone. Okay, I think we're live. Let's get rid of that ticker. Hopefully everyone hears me. We are not in the normal place. We are currently in a small Appa hotel in Tokyo. So because of how uncomfortable this kind of place is, I wasn't going to do a long stream. And I don't have a mic set up, so we're just using the mic that's on my MacBook Pro, and we're using hotel Wi-Fi. So if things don't work out, just let me know. We'll end the stream there. I thought I brought my LAN cable, but I didn't. I usually have like a hard line set up. So we'll try this. If it doesn't work out, we'll just skip this week's stream and do something else. Does look like it's working, so we might continue. But anyway, so welcome to the stream. Today is kind of going to be a more low-level stream. I'm thinking I kind of want to go into the Sokoban kind of rabbit hole that I went into last time. So apparently Sokoban is not one of the classic Atari games, or at least I didn't think so. Or it must be, I don't know. Like I was like looking, there's a special gem for Sokoban, and it's apparently something that nobody's gotten working well. And then that got me into thinking, oh, they didn't. I thought it was part of that like whole Atari thing, and I thought that like the latest reinforcement learning algorithms kind of got through it, but apparently not. And thinking about Sokoban, it has an interesting need for planning and kind of state, right? Like if you want to solve it, you have to have a plan of what route you're going to do, and then usually there's multiple steps to execute that route, right? And if you switch out what you're trying to do partway through, you might get into a state where things don't work. To illustrate that, let's do a couple of Sokobans in Emacs. And I had some interesting ideas, and I'm not sure if they've been tried yet, but I think those could be like enough information to go about solving Sokoban. So, for example, this is the level that I left at last time, essentially, like just playing through the Emacs levels here, and it's a doozy. But essentially, if you push this block this way, you get this kind of pattern where it's stuck. You can push it in, or you put that one in, but there's nothing you can do from there. So you don't want to do that. And in here, I think what you want to do is push this up. Or no, I think what you want to do is you want to push this up like this and then over, and then you want to push that up so that you have freedom essentially, right? You can push this one right, and then you can push it down, and then you can push it right? So like that's part of what my thoughts were, right? Like you kind of have to plan ahead quite a bit if you want to do Sokoban, and also one of the things I thought was kind of like unfair is that I didn't give the LLMs the chance to undo. But when I'm playing Sokoban, I always have the chance to undo. And I think undoing is a part of solving it, right? You got to see, it's like, oh, I can't continue. You got to recognize that you can't continue, and then, undo and then try something else. So here, I think you want to kind of push that there and then push this out of the way over here. And if you do this kind of structure, you still can get behind the boxes, so you can push them out of the way, and you get over the boxes. So this is good, I think, in general. Like, even though I don't know if this is the answer to this particular thing, I can kind of see how this structure gives me flexibility to go out doing that. And this is a kind of dangerous structure here. I can go up and down from there, and with this one, I can only push it left if I'm in the right-hand side. But you need to start filling in the boxes. So this gets really kind of hairy quickly. So for example, what did I want to do here? Yeah, one thing I thought about this opening is that you kind of want to push this up, that one down, and then you can get in here without committing to the box locations, which I thought was kind of like an advanced, maybe not advanced, like simple Sokoban tactic, is that if you're forced, like sometimes what they want you to do is kind of like force a move, so you have to put a box into a corner, and then it's stuck there for the rest of the game. So for example, go back, you can see that in action. So if for example I wanted to go, okay, I'm gonna get in through the top here, I can push down, and I can either push down again and again to now push this to the right. And now I'm in this area and I can start doing stuff, but that box here is in the corner now, and I can't move it. And you know, what's difficult about it is things like this. So let's say I want to go over here and then push this box in. I can't move it to the right, without going through the left first. So if I want to undo my steps now, I can't really do, well, I have to undo my steps here. And when you start, for example, like pushing this box in, you don't have a lot of freedom, you know, like I no longer can get the box in here. Like these two spaces here are now impossible. So what you have to do, I think, is instead of committing to those locations being down there by going through the top, you want to get the top open so you have some wiggle room, right? And then get down in here like so, and then push these boxes in here. Oh, and I kind of messed that up. So yeah, you can see Sokoban is like kind of difficult. This is now messed up. There's nothing I can do here. I can't push that out of the way, so I got to do something else when I do that opening. And I was kind of thinking, with if there was a language model doing this, it needs to have that entire plan in part of its inputs, and it needs to, well, I think, visualize the plan. And then that got me thinking about the way to do that. Now, in Google's Vertex AI console, they have an interesting thing that I thought was good. Let me open it up real quick so you guys can see what I'm thinking about. Okay, so in the multimodal, there's like this prompt designer, and this is the multimodal one, so that gives you access to this, visual one. And I was kind of thinking, let's say we move this to be about as small as it could possibly be, and maybe square. Maybe that's not square per se. And that's close enough. So you can paste images in here, but you can also talk, right? So you have inputs. But you can also paste images anywhere in the prompt, right? I could paste another one in here. And I thought that could be a good way for it'd be like a good data set for this. So I'm thinking something along the lines of like current state colon, and then we have the image. And then we give the model the ability to like imagine the next state, right? So yeah, let me see if I can like explain it properly. So essentially, there's like a structure that I was thinking about. And if I remember correctly, Paul was mentioning, yeah, so there's like, so as an agent, right? So there's observation, right? And then there's target and action, which is what he's talking about. But I was thinking, what if it was more like we allow the LLM kind of do things in a different format? So like, let's say there's this observation, current state, right? And then thoughts, right? I need to pick the next move with action, then move left, move right, move up, and move down, undo, or reset. Maybe not thoughts, but like available actions. Then maybe have something along those. Pick the next move with action with left, right, next start. And what I want it to do, which you can't actually do, right? I want it to imagine the next steps, or that's what I think a good reinforcement, like a general reinforcement learning agent, has to do to do things. It needs the space to come up with n number of steps in the future, right? And from there, make the next action, right? So I'm thinking something like thoughts. If I move, so let's restart it. Or no, that was probably a bad idea. Yeah, let's start from the beginning. I think that might be. Actually, starting from the beginning is not a good case. So let's just redo this state here. So if I remember correctly, I wanted to go up here. Then we'll move this there. We'll put that there. And put this here. Push this up, this down to the left. Yeah, something like that. Okay, so this is the current step. And let's say it has the thought of, if I go up, then I can't do that, because if I move up, this state will be, then we have that state, which is a dead end. or a deadlock. So I must move, and we undo. The original was, that was on the left, right? So let's add that. So if I move right, the state will be, and then we put this state. So I'm putting it like hard-coded, but imagine if it had the ability to kind of call Stable Diffusion as part of its output, right? So we would train it with, so the model would output stuff, right? Like maybe not necessarily Stable Diffusion, although Stable Diffusion does have the ability to be like kind of generated from text. So imagine we had a special start Stable Diffusion thing, end Stable Diffusion thing. Those tokens then get passed through Stable Diffusion, become an image, and then when we put it back into the model, put the image back into the model, not the Stable Diffusion tokens, or both, right? Like the interesting thing, if you could get them both into one, right? So that the model is not just able to do that, but also generate these images, then it could be trained to generate the correct images, right? And here, if we had Stable Diffusion as a separate thing, it would be unable to train it. It would kind of be shooting in the dark, right? In terms of getting the correct output from Stable Diffusion. So only if it knew beforehand how to do that would it be able to learn anything. So yeah, but anyway, like, I was kind of thinking of this kind of idea. So if I move right, the state will be this, and I can either move up or down, right? Yeah, do that, and I can move either up or down. If I move up, the state will be that, and this. So I should move down, right? And then maybe we can have it do something along the lines of, how do I get it? So I want to give it like a goal state that it's trying to do, right? Like, so for me, when I'm doing these things, I'm kind of like imagining in my head having a like a state like this. So I know I can push that in there and do something like this. So maybe I have like this idea of, I want to get into this kind of state, right? I should move down or move help us keep the thing consistent here. So like move left or move down or move left to get the boxes to this state. Right, then we put that in there. So imagine that all of these are imagined, right? Like it has the ability to be like, okay, I want to more or less get these things there, and it doesn't have to be perfect like it is here. It could be like super abstract, as long as it is images that are useful for it to have like this scratch space. And then I can have, then the prompt would be action : and we submit, right? Something like that. Now this is incredibly expensive, so I don't think there'd be any way we could possibly train this in here, but I mean, you don't have the ability to train the multimodal things anyway, so that's fine. But, you know, when it comes to Sokoban, you don't need images, right? Okay, and so the thing responds move right. So we'd like, so you can imagine it'd be like, okay, move right, action move right, and then we'd have some thoughts, and then a new observation. So it'd be like we move right, then we have this observation, colon, and we are way back into here. Our first observation was this state, right? So push that there. Push that there. Okay, and then move right is like this. I mean, I'm not sure we need to chain it, but you know, for example, we could chain the observation, then some new thoughts, then submit, and then get it to come up with new thoughts. Right? Like now you can kind of see like what I'm getting at here. Like the prompt would get longer and longer until we get to context length, and we start cutting off things in the prompt. And then if we had a data set like that, and you did enough training, the model could learn how to do things, and it's doing exactly what I was thinking, right? Like this Sokoban can be done in text, right? Like because it's a classic game, so we don't need to go full multimodal to do that. If the model is able to represent the next states as text, it could probably do that, and you can see it's like trying to do that, but it makes no sense. And I think I might have killed it. Oh, I hope. Token limit 2048. I hope that didn't cost me a lot of money. Yeah, temperature. I think we need a repeat penalty or something like that. But anyway, like I was thinking that this could be possible to generate a data set like that. I think the main problem would be the thoughts section. That's the main difficulty there. What if we what if we kind of do that? With like simple Sokoban things. Oh, and one interesting thing is maybe there's a reason why Google is better at Sokoban. The Gemini Pro Vision is better at Sokoban than GPT-4, because one of the there's a paper by Google on this, but for robotics, and I was wondering if the paper was mainly about their multimodal kind of thing that was used for robotics, and I was wondering if Gemini Pro isn't based off of that. That could be possibly interesting and might explain some stuff. Let's do some like Sokoban basics, and I kind of want things that have that in them. Let's see if there's some simple levels out there in text. Or is there? There must be. Is there a Linux lookup? that I can install with apt or something. I'm not sure. In general, in Debian, is there something like that? Let's check real quick. To increase performance of tunnel, consider installing NumPy. So, yeah, mixture of experts is another thing. And does it understand emojis? I think partially. We can bring up that code. So I used to have. Oh, great. Okay, so that, I guess some tunnels are being blocked or something. Where was it? I had. Let me open up my pie chart. So I made a simple, similar thing to this, but this one, LLM agent RL. And we could totally do this. It doesn't have to be Sokoban per se. But if we run this thing, Python agent.py, it renders the map with emojis like this. And was I doing this with like local models? I might have been. Okay. I don't think RWKV was up to the task in particular, but anyway, like this, it enables you to. We render the map with like ASCII or emojis. We don't send that information to the model, I don't think. Yeah. I think I have a description. Yeah, essentially it's like, this is the thing. And then it's like, it says look north, and then it looks north and it tells you you have a wall. And then look east and it's empty, north, and things like that. And it can move and it can think and do those things. So this is like my previous experiments in this. And we could probably use that to do that. But one of the reasons why I wanted to keep it with ASCII is because there's a pretty standard like Sokoban terminal like character set. Like the boxes are $signs, right? And the player is the @ symbol. Walls are hashes, and rows I think were like dots or something like that. Making games with Python Pygame. Sounds like a great book. Oh, how that. Anyway, so like that's like pretty standard, and I wanted to maybe use that because there's a chance that it kind of knows the rules and more or less understands what that is based off of that. Yeah, these things. What's a plus? Must be a space. Ah, yeah, yeah, it must be a space. Yeah, what are the awesome TTY games? So we got Hangman, yeah, that makes sense. 2048 CLR, that's interesting. ADOM Band. It's been a while since I played ADOM or Ang Band. Gotta try that again sometime. Oh, and I also wonder, back into the like mixture of experts, like could each step forward be an expert, right? Like you have like a special expert that's just trained to predict. It is listed as Emacs. Okay, I mean we could totally do that. I wanted something maybe a little bit more specific, but you could totally do Emacs. Terminal, I don't think I have it on my Mac. I need to SSH somewhere else. Okay. Emacs. Install Emacs. X. That would be good if we do those. It doesn't come with it, you know. Well, let's see. That works on the terminal. And how it works, I'm interested to know. Package, install. Sokoban. Actually, Sokoban. No, that means. What is that? I was using colors. That's not what I wanted. And we're in menu bar mode. That's suspicious. But I do think this is copy and pasteable. Let's find out. Possibly not. It's not. Yeah. Like there's fancy graphics. I don't want fancy graphics. I want like hardcore old school ASCII graphics. Let me search for Sokoban. Maybe there's some good ones. Peruski, that sounds interesting. No, but it's I don't want to install GTK, stuff like that. We're talking about ASCII things. ASCII Sokoban Linux. They're like a very, very simple ASCII Sokoban. Why did it link to actions? It's so weird. The thing I don't like about this is it's HTML and stuff like this. I don't want it all. And push. Okay. Right. Search and push. FP Sokoban. No, there's no FP Sokoban. Oh, not an app. Maybe I can npm install it apparently. But I don't want to install npm on this machine just to play that. New token. Wasn't weird names. You have to program the Sokoban clone. I mean, how hard can it be? Famous last words. Famous last words indeed. The advantage of programming my own Sokoban is that I can use very simple levels, which I think we'll need. So maybe. Ooh, there's a Sokoban gem. Let's look at the Sokoban gem. Although I think that one was graphical too. Yeah, there's this guy who created this Sokoban gym environment, which is great, but you know, it does have tiny world, so perhaps. Maybe 4 understands a piece of one. That's interesting. Let's see if I can do this stuff. Looks like. Put this on this monitor. Okay. Yeah, I don't want that. Not like that. I want it to be something that you can do by itself. Was there so many L5? Yeah, let's make something, I guess, in Minecraft. We're not in runtime. In extra tiny grab. Let's get on that. Either an extra or an examples, but I think examples would be fine. So let's do Sokoban. All right. Now the levels that I want, let's put level 1, which should be something like it's 6 walls here. You know what this reminds me of? It reminds me of like the Minecraft things. Player is there, box is there, and the goal is there. That's level 1. Just gotta go up, right? And you want a model to do that. Well, let's see what Gemini does. So I think this is like the standard representation you might find on the internet. like it old things. Let's just put observation and do that as that. But I need to push the box towards the goal action. Let's put available actions. Move up, move left, move right, move down, reset, undo. Let's put the box over well, action, and submit that. Move right. Yeah, makes total sense. Why would you not want to move right? Boggles the mind. Right? You have one job. Push. Okay. Maybe let's add a key. Right? Okay. If we set this up in a text format, that makes sense. The player is, let's see, okay, this is the player. This is the game Sokoban. Okay, good, presented at walls are at the box is presented by money and goals that presented by box. And these spaces are represented with multi space. Okay. And observation. Okay. Thoughts. Action. Let's give this a kind of head start. So we'll put move right. And then from there, we'll have another observation. Okay, and we'll put that as a space. And then at. Okay. Action. Move down, and madness ensues. It just continuously does it. Yeah, never mind. Never mind. So I had to stop sequence of 1, 2, 3, 4, 5. Actually, that's the interesting thing about this. I don't want a stop sequence should be action. Temperature 0. Yeah, we don't want it to imagine, or that's the thing. What I wanted to do is imagine what would happen if we take that next action. Right? Many steps into the future. Unfortunately, what these models do, because they haven't never been trained on things like this, is that they just make up completely unrelated things. We probably need to fine-tune a model to generate these imaginations. Like what I want to do is make a prompt where it's able to plan a series of things, right? Because that's what you need. That's what you need to do, right? Like you can't just go move left or down or something like that. You have to have some sort of goal in mind for a lot of these, and then see your current state versus that goal. Like that's what's going on in my head, at least. Because sometimes these can be like really long, you know, like you got to go around and through and some sort of pattern. And that's what I think is missing from LLMs, is that they have no ability to kind of have this state in their head that is imagining what they want to do and then the current thing, right? So I do want it to imagine it, but I don't want it to be observation. I want it to kind of want it to be like, need to push the box. Okay, what if we go like super easy? Right? And this is an interesting thing. I think a lot of Sokoban is like the reinforcement learning Sokobans are like with hints. People are using hints with those to get RL to work. Okay, so current observation, available actions, thoughts. Let's say I need to push the box towards the goal. Right? So if I move down, the board will look like, and then have that. And I wish I could change the font. So yes, we have 1, 2, 3, 4, and then walls, right? So there's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And if now what does it do? If I move down, the board will look like. It's not a good move because the blocks will be blocked by the wall. Yeah, it doesn't know what it's doing. Let's no, I don't want to do it. Let's technologic this real quick. Gives us the ability to try various things. It might think it's that. So the problem with technologic is this isn't a language model, it's a chat model, right? So not ideal. But we can do that. So let's put that there. Send. That's a really big. I wanted to disable auto send. Okay, let's do this as a system message. I really want to stop it, but that would be great. Oh God, stop talking. You talk too much. Talk so much. A great way to make money. Okay. So, something like this. So player is represented by @ Walls are represented by that. boxes are represented by $, goals are represented by that. Space, empty space. And the goal is to put a box on top of every goal. And the objective box on top of every goal. Okay, so we have a system message like that. Then we'll have the user say current observation, available actions. Where'd it go? Oh man. There we go. Current observation. This is a user message. Right. And save that. Move up, left, right. Yeah, it makes no sense. Has no idea what that looks like. Although it could be that this is messed up. Save. Can't push the box into the wall. Okay, so this is that. Right. Dots. Followed by predictions and how your move will affect the state of the game. And finally, right action followed by the action, the best action to take. It's not against the wall. Why does it think it's against the wall? I mean, like the first part is good. Let's put one more space. 1, 2, 3, 4. Let's do that. What does this look like? Okay, move up. That's great. That would be good. Let's edit this. Put okay. In that case, this would be a space. This would be $. We want space, space, $, space, 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 at space, and space, 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 space. I think. Did I get that right? Yep. Okay, so this can get that simple case. That's good. Space, space, $, space, Elon Musk. Yeah. That's a good one. Yeah, it could be the encoding that's not good. But like I remember one of my first things when I was playing around with GPT-4 was I pasted in like some Japanese ASCII art, you know, like those crazy ones. And I said, what is this a picture of? And it was able to get it. and explain it, right? So when I saw that, I was like, okay, this is something else, right? But perhaps not so. Like, I sometimes feel like the latest version is not as good as the first one. Okay, let's change this up a bit. So let's change that. Okay, let's put a wall in between these two things. So we'll have to move right, up, left, down, left, left, up, up, left, up, right. A lot more moves. A lot more moves. However, there's a wall directly above the box, pushing the button. This isn't so bad, actually. It makes me wonder if maybe I should do the same kind of thing. I think using ASCII just, I think using emojis will just makes it less efficient. It needs more tokens. Okay, now I definitely want to automate this because doing this by hand will get more very quickly. I'll move right, so space at. But this is exactly what I wanted to do. It's kind of amazing how GPT-4 is able to do it this way, but like the vision, not so much. But it's like yeah, doing it with that is better. But like, I can just search and replace, but entering it would be so much more difficult. Okay, move up. So this at now becomes a space. And that becomes that. And move left. That's actually pretty good. I think it will actually solve it. That's pretty good, I think. It needs to move the box up, not move the player up. That's not going to work. So now we're at the limits. Interesting. Now it's deadlocked itself. If it goes left, it's impossible to win. Let's see if it learns to reset. That'll be, or yeah, it's not learning anything. But. I think the problem is it's kind of thinking, as I often do, about the box and not the player, which is interesting. It's like very natural. Yeah. First parts were interesting, but the rest not so much. Now it's going to get stuck in a loop, isn't it? Yeah. What if move right was not available? Let's do it that way. Let's go back to before it got stuck. And then no actions cannot move up, right? Move up there. And essentially when it moved up like this, move right wasn't available. And when it moved right up here, move right wasn't available. Why above the box? Yeah, it's dumb. It can't do it. Can't do it. Send me that through Slack. I can't copy it. Okay, you did. Start a new conversation. Oh man, that's so annoying. So annoying. No, yeah, that's not going to work very well for technology. Why does it do this? But yeah, I mean, so we don't need to, like, I don't think the problem is the representation. There's nothing wrong with the representation. It is, you can see from the thoughts that it understands that there's spaces and that, these things are walls. But it, it's pushing the box to the left. And that's no good. So if it pushes to the left, it can move up. And now the box is against the wall. And you can't win. I would like it to be like, oh, I need to reset or undo or something like that. But I don't think it will do it. Space, and then box, space, player wall. Because of that, it can no longer move right. And when will it realize its mistake? Yeah. let's try that. I don't think it's going to change anything. You could try. I'll try. Move down. Yeah, it gets that so wrong. Why does it get it wrong? Let's put this in a block for ourselves. And let's put a wall in between. Oh, God. People have no idea how annoying it is to work with this shit. Oh, God. Never mind. I'm not doing it. Not doing it. It's not worth it. And maybe that I think that's still achievable. Push up. It's not the ASCII. It doesn't matter. It does not matter. It's like, oh yeah, fuck the wall. Fuck that wall. I'll just push right through it. If life was that easy, we wouldn't need AI. So yeah, I would really like it to realize that it just failed. Will it ever realize that it's failed? Oh, sorry. Okay, got it. It did pick undo, which is great. Correct. Move up, move left, move right, move down, reset what to do. That's all good. It cannot move left. Move right. That makes very little sense. How long do you think it will take before it realizes? Move left, move right, move down. Cannot move up. I am off by one error. To get below, then up to get behind it. I kind of wonder if this could be just our temperature settings not being configurable, and now it's stuck because it has what it's saying in its thoughts is that it wants to go right and then up, but there's not even a box there, and this thought is actually up here somewhere. So it could be that the temperature has picked the wrong thing, and now it's just trying to be self-consistent with its own thoughts, and unable to continue. Actually, let's see what Gemini Pro does real quick. There is conversation, text chat. Let's start with this system message. And then take that, copy it. Oh no, stop. It is nice that I can stop it, I have to admit. So let's put the temperature to 0. We're in Gemini Pro. Token limit. Our stop sequence is observation. Move right. Okay. Good first step. I gotta admit, I do not like the UI here, and if I got my shit together, I'd finish my Google implementation and technology. I really need to do that. I've started it, but I never finished it. Okay, so it can no longer move right, so let's get rid of that. That move right. So I do. What? Yeah, never mind. It was too much work to do a quick experiment to see if Google's can do it, because I can't delete this and try again, right, like we can do in Technologic. So that sucks. Yeah, that sucks. Let's make this as a small program, and then once it's a program, we can run it on stuff. I think that's fine. Let's say it that way. Okay, so this level I think should be reasonable, but we want to add a wall like that. So, all right, we don't want the wall there. Never mind, that's not doable. I want the wall here. That needs to go right, up, left, down, left, up, left, up, then left, up, right. Right, so it's like a lot of moves to solve that. Okay, then let's copy out this system prompt. Okay, and then user template. And what we want to do is take this. Okay, available actions, and then let's put actions, right? Do it this way so it's not exactly a format string. And then here we'll put observation. Okay, now we create a Sokoban clone in ASCII. Is it simple enough that I can just ask GPT-4 to do that for me? Let's see. I'm interested. Because it's like, I know what I have to do. It's just like annoying. I want to make a Sokoban clone in Python using ASCII. I want the first level to be this. Right. And the user inputs move up, move down, move right, move left, undo, reset to update the game state. Make it fun. Something about that. Fine. Save in place. Let's do it. Should be good. I'll make a Sokoban class. That's exactly what I do. Find player. Not sure I'd do it that way. Or just give the player the state, right? Swap. No, damn it. Screw you. Class Sokoban is great. That's fine. What we want is let's put the level as level 1. Now I understand why. Yeah, I kind of understand why it's doing it that way. What we want is just the walls, like something like that as the level, and then we can have. We're going to be drawing from the top to the bottom. That's from the top. So this is 0, 0, right? We want the player to be at. I could parse it. That's easier. Let me look at this again. Move, and then move. Find the player. Hold on. I don't think you need to find the player every move. You can just have the player state. What I would prefer is that we have the board. We render the board, then we render the player state and the box's state based off of like internal stuff, right? If we do everything by relying on the level, I guess it's not so bad. Now let's try it. Let's see if it works. Let's at least give that a shot. I don't like it like that. I do not. Python. Move right. Okay, move. I mean, it works. Might as well. Move left. Okay, it doesn't work. Never mind. It doesn't work. Not moving boxes. Fix it. I don't want to think. I'm the human. You're the machine. My thought cycles are precious. What it needs to do is it's moving level target is that. Use append swap target swap player. Oh, that's so annoying. Yeah, but it's doing it. That's fine. If it's going to do it, I won't care that much. And the undo function, that is correct. Kind of wish we could have a smart scroll to not scroll when I've scrolled up. That explanation doesn't give me too much confidence. We'll give it one more shot before doing the hard work ourselves. Then undo is supposed to be like that, it says. Sure. I'll trust it. But yeah, it seems wrong. Okay, what's up with these diffs? They're off by one. And again, move right, move up. Okay, move left. And all it does is move right. Yeah. Why do we trust the machines to do things? How do we do this in a way that's not too annoying? What I would do is we have the walls as a layer, and we can render one character at a time. Now, let's start with the. Let's do it this the not stupid way. So we'll have a render function, and we'll have a level which is equal to this. And make each one of these into a string. How do I do the rectangles in that? You can do. Oh, never mind. The amount of time it took me to figure out how to do it in this one instance that I needed. It was not worth it. Okay. And I think we can do it that way. And in our init, pass here. So we have our level. We're also going to want the player, which is the player X. It is 0, 1, 2, 3, 4. 0, 1, 2, 3. The player X will be 3. Y is 4. 0, 1, 2, 3, 4. 0, 1, 2, 3. Some players. Goal X. This works only for this one thing, and I think that's fine. 0, 1. 0, 1, 2, 3. So 1. Box X is 0, 1, 2, 3. 3 box 3. I don't have data classes for things. You have data class, or is it data class? Class entity. And I want these to have a type string x int y int. Is that right? Let's do it that way. So we'll have layer is equal. Let's do all these initializes and things. We have layer, which is an entity, a goal, which is an entity, and a box, which is an entity. And then player is equal to entity type equals layer, and it was at 0, 1, 2, 3, 4, 3. X is 3 and y is 4. Self.clear, and what self.goal is entity type. X is 3, everything's X is 3, and then Y is 1. Self.box entity equals box. X is 3, Y is equal to 3. Then we can leave our level as completely empty, just having walls. And we use that as a state, right? So when we render first for I and 0 to 1 level. Self.level I. Okay. I think we'll render the character. Yeah, let's do it in order, right? So if self.player.x is equal to j, and self.player.y is equal to I, we'll print player. If self.goal.x is equal to j, and self.goal.y is equal to I, then we'll print the dot. Box x is equal to j, self.box is equal to I. And it's easy to make these all be, lists, and then we can do that. And the box is going to be that. Else, right? Then we print the level. So self.level I j. let's do Sokoban, and then let's call render, just to check to see if I did it right. Did it wrong, because there's a new line here. I need to add this to everything here. And then at the end of this loop, it'll print the new line. Is that right? Doesn't look right. Ah, right. These need to be else ifs. There's only one thing that can be printed. There we go. So that makes things a little bit easier, right? And then you can have a move, right? CMD, right? If was there cool switches in Python now? I think so. Which case 310. I'm on 310. I do believe I'm on 310. There's this new thing, match case. Seems about right, simple. So match command case. Make it. Let's make things VI style. Do we want to make it VI style, or do we want to? Well, let's make it VI style. So if I do, it's like if we make a VI style, it's just making it more like difficult. So let's do the simple one. So if we do reset, then we want to essentially call init. Just call reset in here. We'll create a def reset self. So we self.reset if we do that. And then we also need self.moves, which is a list of command strings. Or is it a list of states? I'm trying to optimize for implementation, not coolness. So if we just, every time we move, we take the current state, throw that into the undo buffer. Then if somebody undoes, we just take the last state, rewrite ourselves, right? That seems pretty easy. What version of Python am I using? Goddamn, okay, no, can't do anything fancy. In that case, I'm just going to do the move stuff here. Then we'll have a game. We'll do game Sokoban. Last game that has states, the list. We'll have a def play, which is while true, use Sokoban render, right? Print. What did we print before? Enter your move. All right, well, an input. So move is equal to input, enter your move. So we can now set undo. Let's put R in move just to make things easier. And then we'll do, okay, so the board is equal to none, and we'll have the def init self board. Board is equal to that board. States is that. Let's give this a type instead. The board is a Sokoban, and states is a list of Sokoban. Do things the functional programming way, just make the undo easy and rendering easy. Right. Sounds good. Okay, so not while true, but while true, we will take the board self board render, enter the move. Okay, then once we have the move, we'll do self.board.move. That gets us a new. So we'll do self.states. Append self.board move, and then we set self.board to the result of that. Okay. Yeah, let's do it this way. Get board is going to be equal to Sokoban there, right? Sokoban is there. Reset, render, move, and undo. So if move is equal to u, self.board is equal to self.states.up, right? Else if move is equal to r, then board is equal to Sokoban, right? And then self.states. Let's reset. Self.reset. Self.reset. Then def reset self. Okay, now we have that. Then we all reset if the move is that. Else we append the state of the board and then we move accordingly. Let's do that if we can move. So else if self.board.can move then we move. Can move self command. Okay. We don't need this reset. We'll just commit ourselves like that. And render, and move. That's where we do things, and then move. And by doing it this way, we can just assume that there's no illegal moves. There's always going to be a move check first. So in move, we have a simple if command is equal to h, and we might have to trim. That. I'll look at that later. And then we want to move left. So assuming everything works, self.player.x is equal to self.player.x minus 1. And is L, then self.player.x. I'm not sure if you can mutate data. We'll find out. Somebody let me know if I can. That'd be helpful. If it's J, then self.player.y is equal to self.player.y plus 1. And why am I doing this? We can just plus equals, right? Minus equals 1 plus equals 1 plus equals 1. So if command is k, and we want to self.player.y minus equals 1. Those are all the moves we can do. We can move, we check if. The can move is where the main logic kind of happens. We need to check one, if there's a wall or not. Oh, something broke over here. Okay, hopefully everything still works. Kind of noticed my computer's CPU fan started going down, and then StreamYard just decided to die. So not sure if you guys missed anything. Anyway, so can move is where the real meat of it is, right? The simple case is the player is going to move into a wall, can't do it. The other case is the player is going to move into a box. Then in that case, we need to recurse down in the can move. So can the box move into a wall or not? And I think that will work, right? So that's the functional programming thing. So we need to have the entity the command yeah, I guess that's the best way to do it. So we want a new x is equal to if command is equal to h, new x is equal to self.player.x minus equals 1, or minus 1. Y. I have a feeling I need to do something else. Like I need to kick off something in can move, right? We need to go from moving the player to moving other things. and you can only move one thing, right? So you can't move two boxes. So the amount of recursion isn't crazy ever, I don't think, unless you have some crazy, super crazy thing. Let's put L x is self dot x plus 1 y, and the became is j x, and then the y is self dot y plus 1. So I do nothing for the others. Self y minus 1. Okay, so now we have this new x and y for the player, and then we want to recursively check things. So check move new x, new y, something like that. Then move self entity x, y. It's the entity matter. I feel like it does. Okay. Feel like we want to do that. Let's type everything here. Let's give ourselves the greatest chance of success. Entity int and include move to string and none. Or no, wait, it shouldn't return that, it should return the new board. You cannot do that? That's annoying. I shouldn't be too surprised. It's not like Python is it's a function program. Whatever. Let's do. But I do want it to return something. So Sokoban is a board and a class that has some sort of language. There, are you happy? Are you happy? Or am I reading that code? The word is not defined. There we go. I guess we call move, can move, and render. Yeah, so that's what so we want something that does render with move self commands with move self commands board. Good. We have the same. Okay, we'll just not specify what it returns. I guess we don't really need it, because we classify our board as a Sokoban. So that's fine. Okay, so we have that, and yeah, we definitely don't want to do this if we're doing this. I forgot about that. So what we do for move, gotta move the boxes. And you made yourself a grilled cheese sandwich. I could go for a grilled cheese sandwich. Oh, am I this dark? Wait, my video has stopped. Am I still around? Does anyone hear me? Yeah, my video is like completely dead. Weird. Okay, so I am around. You guys can hear me, but can you see me? So dark and not moving. Yeah, so strange. So that's what happened. Something is weird with my video. I change my camera to something else. There we go. I think we're back. Okay. But anyway, so what I'm doing now is implementing Sokoban in a kind of functional style. And yeah, right now I'm in this is the hard part when it comes to moving and checking if that move is a valid move or not. I think checking the move is a valid move is an easy recursive thing where we check if the entity is moving into an empty space, and if so, then we allow it. If the entity is not moving into an empty space, then if it is a box and yeah, so the player is able to push the box and that's it. The box cannot push another box. So yeah, I guess we'll do this simple. Okay, so base case, if self board y x is equal to space, return true. And if self.board y all right, a board doesn't have the players in it, right? So we kind of have to check the box or something like that. So in this simple thing, we just check so if the board is base case, the board is that, we return false. Simple as that. Cannot move into that. Then if self.board yx is equal to an empty space and what else do we need to check? if the player is moving. So we have a thing, it's moving to the empty space. And we have to check the box, right? So self.box. Okay, so we're moving the player. I guess the other thing is if self.board y x is equal to dot, right? We do, no, we don't have that, we have the goal. Okay, so if, let's do that check for the goal. So if self x is equal to self.goal.x and self.y, I have a feeling I'm doing something not great right now, and probably should be able to do it better. The state is just this string, right? This. Yeah. Okay, so the reason why I put it into true false was so that I can implement this kind of style where it's like, if that move is a legal move, then we do something. And if it is not a legal move, we don't change our state. We just re-render, right? And move itself needs to be a transformation function, right? So, or not a transformation, it needs to return the new state. That's what I want it to do. That way we can have just like infinite undo easily. We need so the thing about, so I think actually we can have the box in here as part of the state, but we can't have the goal, right? So the box here can be pushed into and out of the goal, and a box in the goal needs to kind of be green or correct, which makes the ASCII version very difficult, huh? Yeah, I guess that's true. It's kind of like really difficult. We have a box in the level, and we don't need instead we could have a state I guess my main thing is I don't like this idea of bind player or move. But if you have the player in there, don't know. Do you think find player is a reasonable thing? The thing about having the find player thing is essentially the state is just your box and target can be different. So that's true. But it's also essentially what you want is to get rid of the dots, right? Like in terms of like the ASCII representation. If there's no more dots, then you win. So the main thing is moving the player is just an instance of changing the string. Yeah, there's more code that way, I'm pretty sure. More code that way. And given that we're just going to be doing a simple level and nothing else, right? I'm not going to go too deep into it. Change your player. Then we do this check move. If we are at a wall, doesn't matter what we are, we can't move there, right? If the board is empty at that location, and self.box.x is not equal to x, and self.box.y is not equal to y, then we return true. I guess that's what we want to essentially return. Now, if we have a box in the way, self.box.x is equal to x, and self.box.y is equal to y. We return check move the box x1. And then yeah, because we only have one box, right? So like the case of moving into a box doesn't exist. So if it's not a wall, we can't move there. The check move is kind of simple in this particular case. And then move itself, we don't want to do anything here. Let's just do new x, new x, new y, new y. Oh, whoops. Okay. New x is equal to that. New x is equal to that. New y is equal to that. New y is equal to that. Okay, and based off the move, we have the new thing. Then we'll do can we do a new Sokoban here? Got a new box. not just the player. First, let's just deal with the player. We have a player and box. Goal is always in the same place. None, box equals to none, that, it's none, that's no, things like that. I think that works. We don't need moves here. So we want to pass the player. The player in X and Y. Box is equal to empty box. How do we do with the box? For the box, we need to know the direction we're going. Let's do it this way. It's 0. And we do X is equal to -1 and 1. And then if it's J, then y is equal to 1 minus 1. And then our new player is a player with X being the new X and Y being the new Y. We're going to assume that can move has been done, right? Self.player.x plus new X and self.player.y plus new Y. And if self.box.x is equal to new player.x and self.box.player.y, we need to move the box. Base case entity box X is equal to self.box.x, Y is equal to self.box.y. Mini box. Let's do it this way. That will go to entity equal to, I like the new entity one. Okay, and new entity box X is equal to self.box.x plus new X box.y plus new Y. Okay, so now the box will move in the direction of the player if the player is moving into the space of the box. So it copies the move of the player. Let's see how dumb I am. Move. Box. Just print. Move it'll move. You can't do it. Okay. How far away are we? We've got board. And it's board. Sokoban. Then as the attribute render. Right, so let's play. I'll move left. Check move is not defined. Move is not defined. Yes, self check move. Did I not save? Okay. Sokoban object has no attribute board. Check the board. Not called board, it's called level. H, L, 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 don't do that. A, H, yeah, that's done. Okay, so our recursion stopped because if the entity, right, so we want to check this. So if the X and Y is a box, then we check move box, right? And this is going into an infinite loop. So if entity not equal to self.box, right? Right, up, left, down, left, up, left, up, right. Okay. And then that didn't work because we're rendering the goal after the box. So we want to render that's the box first. Right, up, left, left, undo, cool, left, up, right, cool. So that works. Reset works, but going up, not what we want, which is what I was thinking. So can move or check move needs another thing here. So if it is a box, and we recurse check move box X. We can't check with just X and Y. We need the direction. Let's change that up. So essentially, we need to go. We need to know which direction the box is going, essentially, right? So can we check move X and Y? We just want to do a dx dy. If we have a player and we have a dx dy, we check the next thing. If it's space, then okay. If it's a wall, it's not okay. And then if there's a box, curse check move box, and the same dx dy. If it is an empty space, it's good. If it is not, it's not good. Y0, if h dx is equal to -1, if L dx is equal to 1, J dy is equal to 1, and if K dy -1, D as in change of D, right? So check move of the player, and then from here, to know the X and Y, we need to use the entity, right? So let's change this to dx dy. Then X is equal to entity X plus dx, and then y is equal to entity y plus dy. Now, if the board, if there's a wall at that X and Y, we return false. And then if this is a box, if this is not a box, but we are moving into the box, check the move of box with the dx and the dy. So here we have the else. So this is a box, and we really only care if it's empty. Yeah, I think that could work. See if I'm wrong. Go up. Nope. What did I do? If entity, this entity is not a box, we check with the box. So there needs to be an else case, right? If we are box, if we are a box, we don't want to check. Okay. If checking player, if we're on a box, we want to check the move of the box, and that is essentially, is it empty? that space or not. That seems correct. What did I not see? Yeah, that would not work. So we check -1 here. Then we do check with this -1. That is not an empty space. We are doing that anyway. Checking box. Dx and dy. And y is y, x is x, and x, y, and yx. Let's debug ourselves a little bit. Going up. Y is 4,3 board of yx is empty. Yes, that's true. That's true, right? Because there is no box in the level. What am I missing? Yeah, there's no box at that level. 4, 3. So if we're here and we're checking up here, that's good. So if we check the move of the layer, it should be -1. Checking the current entity and not the entity of the board or whatever. Right? Box dx dy. This is why I didn't want to implement. I'm spending too much, probably spend the entire thing implementing Sokoban. It's not what we came out set out to do. It's only happening once. Let's see. Yeah. It's funny that actually works. I was kind of not expecting that to push the box, but we've implemented pushing. If the x and y is the same x and y as a box, or b box in this case, you want to do it that way. And then for the box case, we are a box, so this x and y should not be the same as the box now. What? let's give ourselves some printing debugging. Print the x, print f dy is equal to y, print f x is equal to x, which we have to do down here. Print y is equal to y. Type is okay, so we're just doing player. Dx dy is 0. Why is it 0? What did I do? That's why it's not working. Can move. Command move page to take. How did that? We can't do that. That's right. Okay. So logic was fine, but I forgot this one equals sign. And Python's like, oh yeah, dy minus 1. That's totally fine. Oh, you're not doing anything. That's perfectly fine. That's probably what the person wanted. Yeah. We program in this, like our technology when we program is the same as it was in the 40s. It's ridiculous. At least I'd like to go into like the 70s, right? You had languages that could do type checking. Anyway, okay, 1 a.m. We have a Sokoban game that we can play around with. I'll move like that. If I do strange stuff, it doesn't matter. Move right, put stuff up, and go into a wall, still go down, go up, undo as much as I want. Yeah, and then if I pop them into this, that's not gonna work. So into U and self.states, and self.states is greater than 0, then we pop. Undo. Okay, and let's go to that print statement here that we don't need. Okay, so hopefully that's a Sokoban level. A decently complicated one, right? Yeah, I kind of expect that maybe a 5-year-old can do it. I guess we should do a while self.board.box. So self.board.box, self.board.board. And once that happens, we print You win. Why not that? And that. That's the logic, I'm pretty sure. Yeah, cool. Can we get a model to play this? Sad thing about V001 is it doesn't have a GPU, which might make things a little bit slow. We do have VEs. Now let's check that transformer. We have that transformer, right? Because there's one Python transformer I. Compile stuff. So step one is done. We have a Sokoban level that we can play with. Can we train an LLM to do that? Makes me wonder about gym environments. What did that look like? Gym. Kind of crazy to think that gym was created by OpenAI. Okay, gymnasium. Farama Foundation. Okay. So is it possible to do this with just text? I wonder. So strange. Like GeoHot was doing like reinforcement learning the other day too. And I don't think me wanting to do Sokoban or like that was at all related to what GeoHot was doing. I think I saw it in a blog post about a guy who was like how much he loves Sokoban. And for some reason, I started trying it, and I remember how much I hated it. But now, after reading that guy who loved it so much, now it's like, hey, this is actually really good. I don't know. Like, so you have to be a very special kind of person, I think, to really enjoy Sokoban. Because it's like, eventually, once you understand what you have to do, it's like, okay, now that's the bullshit, right? Like, go and do the thing. And it's usually like just really roundabout ways that you have to do things, and people don't like to do things a roundabout way. Okay, so yeah, this happened. Now this is weird because I think a couple of commits before Paul's commits were fine. Like we were able to run transformer when we started doing this, but recently there's some change that caused that to not work, and that's a problem. Where are we at? Master. And I don't have new master. I don't want to change things. So the interesting thing about this is, watch this. We have Python benchmark train efficient node with VEO. 25 gigaflops, right? I can do batch size of 64, something like that. Using device VEO, compile some new stuff, and we're getting better performance, right? Gigaflops there is better. Let's make this full screen. So let's go to our GPU server, XAI VE3. Okay, and in here I have projects EE TinyGrad, essentially the same thing. Let's really big activate. I shouldn't type so hard. Then we go to the examples, Python. So VEO equals 1, batch size equals 64, Python benchmark very efficient. Actually, let's not do the bench because it's like slow. Let's just do it this way. And the code is exactly the same code because I copied it. Right? This isn't like a git commit that's the same git commit. No. I took the code that is running in BH001, copied it over here, and I'm running it in XAI VE3. And it's slow. I don't know why. Yeah, let's go into that. Okay, so running with this, all right, batch size 8, we expect 25 gigaflops. Not great, but that's fine. And I might be running with like the crazy settings right now, so the compile times are kind of ridiculous. But I'll undo that. Crazy settings are ops VEO. And here I have the floop unroll complete. If you set this to a ridiculously high number, you double the gigaflops. But the compile times are exponential. And then that's kind of what's going on here. But if we are running this 1024, should expect that 25 gigaflops on here. And when I was doing this the other day, we didn't get that. And I don't know what the delta is between the two servers. Now, there is an obvious delta. This is CentOS 8, and VH001 is running CentOS 7. So there is that. I just don't expect there to be that big of a difference between CentOS 8 and 7. Unless it's like configured wrong, right? The performance we get is there's some sort of problem in the configuration type of thing. Now, how long did it take me to implement Sokoban? Like an hour and a half? Might be a good interview question. That's a terrible interview question. It'd be kind of really long. I'm not sure my implementation is any good. Right? You don't want it to have just one level, and one box. You want something to be a little bit more generic than this, I think. So I wouldn't say that I have a good implementation. Is the VE running in a slow PCIe mode? Possibly, but why would it be in a slow PCIe mode? The A100 is not in a slow PCIe. That's for sure. I guess while we're doing that, we can also look at the A100 do its thing. Let's the tiny grad. So let's activate samples. Then CUDA equals 1. Yeah, so with the A100, we're getting 133 gigaflops on here. So that's pretty good, I think, if we were to increase the batch size to something ridiculous. It gets crazy. It just keeps going. So, and that's not unexpected. It is a convolutional neural network after all. Yeah, 350 gigaflops. So PCIe, at least on the motherboard, is fine. But that's true. Let's go to extra DMMM. So we can't run the so on this computer I don't have NLC Pi. Can I copy it from here? NLC Pi build a dist. Do I have a dist here? Ooh. This is 3.9. Is there a AVO benchmark? Where's the AVO benchmark? In the source? I see. Okay, so let's get out here. Get that. Get that. Let's look for AVO. And that. Which one is the benchmark? I think I'll only stream for another 15 minutes or so. I do have a kind of like early morning tomorrow. Okay, so that has been made. Okay, and then is there a test benchmark? Let's just run the tests. I should probably do VE. Number is number 2 and number 1. Scan bandwidth async. Test. Oh wait, there's some scripts. What's in the scripts? Okay. To test and scan bandwidth async. Something's not right there. But I have the feeling that, well, there's no code here, right? So we need some executables, right? Okay, scan bandwidth async node number one. Okay, now let's go back here. Make it 001, and then we have something to compare against. Yeah, look at that. 0.49 gigaflops. And before, when I was testing this, I was able to get 0.8. And that's it. I need to SCL. Another SCL. So yeah, so it's surprising, but like, it's true that I haven't run the VE on CentOS 8, so ever. So it could be that I'm just like missing some configuration, or there's some configuration that's like wrong. But I do think I ran everything in the install guide. Might be wrong. Okay, so now if we go to build, bin, scan, and async. Okay, let's compare. One 674, 2,300, 1,000, more or less in the same ballpark. Though on the bigger side, it does seem there's a significant difference. EPS AX. Oh, right. Yeah. Okay. Yeah. Yes. Where is VA0 zone? There's two. Yes, that makes sense. After we see then we can go for topo. All right. Let's see topo. Shows what I wanted. I want to see the topology. Maybe something is not good. We want topo something. I can't remember what it was. Yeah, it's just like weirdly slow, right? But if we do, let me see, the NPS, EPS, AX. Yeah, nothing running on it. So it's weird. It's really weird. We want the command troubleshooting guide. That'd be a good thing to look at. So, topo. There's that topo. Let's see. Okay. State get. What you need to run as root. Weird thing. A topo tree or something. Is that it? Yeah, that's it. So there is this, right? Like we can see that VE0 is in socket 1, VE2 is in socket 0. So perhaps let's do VE node number equals 2. I haven't tried this one. Could be a socket thing, but maybe not. I don't expect there to be that big of a difference. Temperatures, I think, are good. Core, yeah, nice and cool. Because they're idle and the fans are blowing full blast. We are the most loud server in that data center. Literally, like it's not a small data center; it's a big data center. And my rack is the loudest, for sure. You can hear it above the other ones, and it's like ridiculous. We have four servers running full tilt on the thing. It's crazy. Yeah, 0.49 gigaflops. Exact same code. Weird. I do want to try NLC Pi. So I did build NLCPy, right? But it's not 3.9. It should be 3.10. So is this part of it, or is this what I built? So which one? And I don't want to build it on stream because it like literally took 6 hours or something like that to build an LCPy. Is it assuming that I built? I don't know. I guess we can find out. Let's just copy these eggs. Into I think it's fine. It's so slow, so slow. Okay, let's go to projects, EE tiny grad, copy the eggs into here, then pip install startup egg. Install NLC. So path does not exist. What? How do you install an egg? Yeah, exactly. The PyPy is only 3.8, and we are running 3.11. And then here, we go to the tiny grad. Tiny grad supports 3.10. So this is running. Oh, okay. So running 3.9. Didn't it say that it needed 3.10? Oh man, that sucks. I mean, I could. I don't want to build it. It takes so long. It generates 100,000, 200,000 line C files and compiles it, and you saw how much time it takes to do that. And it causes out of memory errors in the compiler, so you have to like keep restarting it. So you can't just set it and forget it, right? I could. I have the feeling that tinygrad was 3.10. Why is it not 3.10? I thought it was. It says requires greater than or equals 3.8, and I know that's wrong. And you have 3.9. How much time do we have? I said I'll stop at 1:30, so I'll do this in maybe the next stream. But yeah, we can install 3.9 on this computer. Don't really want to. I think what I'd rather do is just build it for 3.11, and then try NLCPy and see how that works. But anyway, that's the stream for this week. I think I am not at home, so can't do things till 4 a.m. And I think that neighbors might start getting angry if I'm like on a call at 2 a.m. So I'll end the stream here, and yeah, be available next week. So we'll be back on stream on Tuesday in the morning, so PM US time, or again same time next week on Thursday, AM kind of European time. Definitely think there's something to giving LLMs like the space to imagine and think. And I don't know if that's like reinforcement learning, because reinforcement learning doesn't work very well. So I'm not sure if we need to do anything about that, but I'll continue working on it. It's something I think is kind of important for an agent to be able to think, to be able to do things long term, like a Sokoban puzzle. Right? You have hundreds of steps that you need to think of kind of ahead of time, and when you're doing it as a human, you don't have the perfect picture. You have a picture of more or less what you want to do, and then you can do the next action to get you closer to that. So I just want to give it that kind of ability. It's like, here's the state that I want to move things into, then do that, and then from there kind of continue. And I have the feeling that multimodal thing is a very generic kind of solution to that, but we don't necessarily have to do that for Sokoban. It can be a ASCII thing. So probably in the next stream we'll maybe do something like that. Have this Sokoban set up, have NLC Pi set up, ideally fix whatever is going on inside of VE3. Yeah, and then do some training on the A100, see if there's some experiments we can do to get it to solve Sokoban. So yeah, so that's all for today's stream. I will see you guys next week. Have a good day.